This is my Physics 2212 Lab 2, which is about lines of charge. So to introduce my lab report, Lab 2 includes many of the same principles as in Lab 1. In Lab 1, we use properties of electric force, induced charge, equilibrium, and the gravitational force. By balancing the electric force and the gravitational force, we were able to reach the goal of the lab and calculate the charge and number of electrons on a piece of tape by measuring the distance between the two pieces at equilibrium. In Lab 2, we take that a step further and we more accurately model the charge tape as a line charge using the concept of distributed charges. We did need to make assumptions for this lab. So based on the Penn test in Lab 1, we assume that the induced charge on the U-tape is positive, and because the two pieces of tape repel each other, then both of the pieces of tape must be positively charged because opposites repel. For Lab 2, we neglected air resistance on a moving object. We assumed that each piece of tape has about the same amount of charge, and we assume that the charge is evenly distributed across the tape. So for Lab 1, we found that the top tape was suspended 1.43 centimeters above the bottom tape. Using the distance and the fact that the electric force, which is the constant K times Q squared over D squared, is equal to the gravitational force, which is the mass times the gravitational constant at equilibrium. We calculated the charge on the tape to be 6.68 times 10 to the minus 9 coulombs. So for Lab 2, we use the same distance, but modeling the tapes as a uniform line of charges. I calculated the new total charge to be 1.96 times 10 to the minus 3 coulombs. This was done by creating 10 DQs, which are numbers of charges, on both the top and bottom tapes, then summing their interactions. We ignored the interaction between each DQ within each piece of tape. So question 1 asks us to compare the charge estimates from both labs. In Lab 1, as I said, it was 6.68 times 10 to the minus 9 coulombs. In Lab 2, it was 1.69 times 10 to the minus 3 coulombs. So our findings were that the estimate from Lab 2 calculates a much larger charge than in Lab 1. Now question 2 asks us why these estimates differ and which value is more likely to be closer to the real value and why. So these estimates are different because calculating the electric field and therefore force from a point charge is different than calculating the force from a line charge. Estimating the first charge as a point charge directly above the second creates a single vertical electric force. Estimating each tape as a line of point charges means summing many forces at varying angles. The line charge estimate is more likely to be closer to the real value because a piece of tape more closely represents a line of distributed charge than a singular point charge. The charge on the physical tape is distributed across the entirety of the tape. So for my models, these are the first two parts of my GlowScript code, including physical constants, measured mass, our E-field and E-force calculations from Lab 1, the code that creates the uniform point charges, and the calculations in finding the E-field and electric force on the top due to the bottom and the bottom due to the top. And this is the physical representation that code created.